Okay, let's get started. X squared plus 20x plus 75 equals 0. It says solve each equation by completing the square. The first step to completing the square is to move the constant to the other side. What is the constant? 75 is our constant value, right? Because all of the quadratic trinomials are in the form ax squared plus bx plus c, and c is constant. So if you want to move this 75 to the other side, you're going to have to do what? Subtract it over. So then you're going to end up with x squared plus 20x equals negative 75, because you had to subtract it over. That's step one. Move the constant to the other side. Step two is identify the b value, divide it by 2, and square it. Well, what is the b value? 20. When you divide it by 2, you get, and when you square that, you get 100. You're going to take that 100 and you're going to add it in on both sides. Now, for those of you who write really big, you're probably going to need out some scratch paper because this is a lot of steps. Okay, now, on the right side, it's easy. You just combine them. Negative 75 plus 100 is 25. On the left side, you factor it. And if you've done everything right up to this point, this is going to be a perfect square trinomial every time. And what I mean by that is the factors are going to be identical. X times x will be x squared. And then what number multiplied by itself will make 100 and added to itself will make 20? 10 and 10. They have to match. That's why it's called a perfect square trinomial. Okay? So basically, every time, it'll just be the square root of that number. The square root of 100 is 10. 10 times 10 is 100. 10 plus 10 is 20. Okay, now, the reason it has to match is because in the very next step, you're going to write it as a binomial squared. Okay? And you're never allowed to do that unless they match, right? Okay, so now, it seems a little silly because we literally just created that squared, but now we're going to get rid of it. How do we get rid of this squared? Square root it. And then if you square root one side, you must square root the other side. Okay, those cancel each other out, leaving just the x plus 10. And on the right side, what is the square root of 25? 5. However, last week we talked about something. If you're ever solving for x and you square root to get your answer, what do you have to put on your answer? Plus or minus. Now the last step to get x by itself is to do what? Subtract this 10. When you subtract it over here, it cancels. And look, when you subtract it over here, you end up with a positive 5 minus 10, which is negative 5, and you end up with a negative 5 minus 10, which is negative 5 minus 10, negative 15. So your solutions are negative 5 and negative 15. Now let's talk about a couple of reasons those are the solutions. The first reason that those are the solutions is because if you plug them in, the x places of the trinomial, they will make it equal 0. Watch. Okay, so x squared, but instead of x, I'm plugging in negative 5. So negative 5 squared plus 20 times another x, where I'm putting a negative 5, plus 75. Okay, see how I literally just retyped in that trinomial, but in the two x places I put negative 5s? And when I hit equals, I get 0, which is what it says it should equal. So that means negative 5 is good. Now I need to try it with negative 15. Negative 15 squared plus 20 times negative 15 plus 75. So this time I just retyped in that trinomial, but with negative 15s in the x places, and I get 0. That's why sometimes these solutions are also called zeros. The question may say, what are the zeros? Well, they're asking for the solutions when they ask that, the numbers that make it equal 0. Okay, another way you can confirm that you have the right answers is to graph it. X squared plus 20x plus 75 we see a parabola, and you can tell it crosses right here, which is -5, right? And then you can tell by the way the curve is that it's going to cross somewhere over here, which would be the -15. And if you want to see it, you just go to your window and go further to the left, like over 20 units. And then when you go that far over, you can see the -15 intersection. Okay? All right, now let me say one more thing. You do not have to write this down. I just want you to watch. Because my answers came out to be nice whole numbers, okay, my answers came out to be 2 nice whole numbers, that means I could have factored it right away. I didn't even have to do complete the square process. What 2 numbers multiply to 75 and add to 20? 5 and 15. 5 times 15 is 75. 5 plus 15 is 20. And then when you factor, don't you just set each of those factors equal to 0? And then to solve this one for x, wouldn't you just minus 5 on both sides and end up with x equals -5? And to solve this one for x, don't you just minus 15 on both sides and end up with x equals -15? So what should you always check for first before starting the complete the square process? No, you want to check first to see if they can be factored. If you can think of 2 numbers that multiply to this and add to this. If you can't think of 2 numbers, you have to do the complete the square to get the answers. Okay, so let's look at number 2. Are there 2 numbers that multiply to -24 and add to -10? Okay, let's just take a look at 6 and 4 for a second. I wouldn't write it down. If you do 6 and 4 and you want them to add up to a -10, wouldn't they both need to be negative? Well, is a negative times a negative going to make a negative when you multiply? So 6 and 4 are not going to work. What other numbers multiply to 24 and 12 and 2? Let's try 12 and 2. Okay, what kind of 12 and 2? Okay, do those add up to -10? Do they multiply to -24? So those are your factors. But those are just the factors. Those are not the final solutions. To get the final solutions, you would set them both to 0. To solve for this one, wouldn't you have to minus the 2 to the other side and end up with x equals -2? And to solve this one, wouldn't you have to add 12 to both sides and end up with +12? So those are the actual solutions. Those are the 2 numbers that when plugged in would make it equal 0, and those are the 2 places where it would cross the x-axis on the graph. So yes, you should always check first to see if it can be factored, because factoring is a lot faster than completing the square, right? Okay, so let's look at number 3. Can I erase this? All right, number 3. Are there 2 numbers that multiply to -14 and add to -10? Okay, because 7 times 2 is 14, but 7 and 2 won't be 10. 14 times 1 is 14, but you can't add them to get 10. So for this one, we're going to have to do the completing the square process. So what do we do first? Right, move the constant to the other side, which means add 14 over. So once you've done that, it'll be x squared minus 10x equals +14, because you had to add it over, so now it's positive. Then what do you do? The b is what? And you do what to it? You said x, not -10. So you don't take x, you take the coefficient of x. Okay, then what do you get? So x squared minus 10x plus 25, and then 14 plus 25. You add that to both sides. Now on the right side, they're both constant values. What do they combine to be? And on the left side, you factor it into 2 binomials. And what do you know about these 2 binomials if you've done everything else right so far? Well, this is a perfect square trinomial, which means its 2 factors will match. -5 and -5. Okay, because they add up to -10 and they multiply to 25. Now the reason they have to match is so that in the next step, you can just write it once and square it. That's known as a binomial squared. And you can never write a binomial squared unless you have two binomials that match, because it means there's two of them. Now what do I do? Right, square root both sides. Those cancel each other out, leaving x minus 5. And then on the right side, when you do the square root of 39, are you going to get a whole number? Is it a perfect square? So instead of changing it to a decimal, just leave it up under the root. However, you still have to put plus or minus on the answer. So now the last step to get that x by itself is to do what on both sides? Add this 5 over. Cancel it on that side and add it over here. So you're going to end up with two answers because of the plus or minus. You're going to end up with a positive square root of 39 plus 5. And you're going to end up with a negative square root of 39 plus 5. And so those are your two answers. That's why you weren't able to factor it, because look at what the factors would be. 11.2 and negative 1.2. Okay, write that down, and then I'm going to show you something on the graph. Okay, see how I just typed in this trinomial into the graph, x squared minus 10x minus 14? And when I graph it, let me go back to my standard window. I see one intersection with the x-axis right there. Well, doesn't that look a hair past negative 1, which would be that negative 1.2? And then the other one is 11.2, which would be over here. Well, to be able to see it, I'll have to go to my window and go further to the right. So I'll go like 15 units over. And doesn't that one look like 11.2 right there? Right past 11? Okay, let me show you something else. Not that you would ever want to do this, I'm just showing you. 11.2, as a factor, wouldn't that have been x minus 11.2 and then x plus 1.2 had you been writing these answers in factor form? Well, what's negative 11.2 times 1.2? Negative 11.2 times 1.2. Which is very close to what? Well, yes, and weren't we trying to find a number that multiplied to negative 14? Why did it not come up exactly negative 14? Right, we rounded. Had we not rounded and we'd have taken each of these numbers the way they were and multiplied them together, watch what would have happened. See how I have both of them now and I didn't round them off and I'm multiplying them? Exactly negative 14. Those are the numbers that multiply to negative 14. And then if you add those two numbers, won't negative 11.2 plus 1.2 add up to negative 10? Okay, but do you really think you could have ever thought of those numbers just in your head? So that's why we have the complete the square process to figure them out. Okay, number 4. Can we factor it? Okay, what are our factors? Negative 10, positive 2. Okay, that will work because they add to negative 8 and they multiply to negative 20. So then all you have to do is set them each to 0 and solve, and you're done. To solve this one, what would you do to both sides? You would add the 10, and so your first solution would be right. And then to solve this one, what do you do to both sides? And so v equals right. Okay, and tell me some things you know about those numbers. I mean, regarding this problem. Don't we know that if we graphed it, this would be the two places across the x-axis? And if we plugged in 10 into both v places, it would give us 0, or if we plugged in negative 2 into both places, it would give us 0. That's why sometimes you'll hear people call these zeros. Instead of solutions, they'll say, what are the zeros? And those are the zeros because they make it equal 0. Okay, number 5. Can we factor it? I'm leaning towards 9 and 3, but will they work? I think so. Positive 9 and 9 minus 3 is 6. 9 times negative 3 is negative 27. So that one can be factored. And remember, guys, if you're ever looking at one and you're not sure if it can be factored, graph it right away. B squared plus 6b minus 27. Doesn't that cross exactly at negative 9 and exactly at positive 3? So that means it can be factored. You would set each of these to 0, and that's how you would end up with your negative 9 and positive 3. Because you would have to subtract the 9 over, making it cross at negative 9, and you would have to add the 3 over, which is why it crossed at positive 3. It's just starting to kind of make sense. Okay, what about number 6? Can it be factored? But are they going to make a 20 when you add them? Okay, look, let's graph it right away, and that'll answer our question quickly if it can be factored. P squared minus 20p minus 36. Okay, see how that one crosses in between the negative 1 and the negative 2 notch, letting you know it's negative 1 point something? That lets you know it can't be factored, and we're going to need to complete the square. So what's the first step in completing the square? Right, move the constant to the other side. So we would add it over, and it would become p squared minus 20p equals 36. What's step 2? Right, and what does that give you? Okay, and you take that 100 and you add it to both sides. And if you've done everything right so far, this is what kind of trinomial? A perfect square trinomial, which means what about its two binomials that it'll make? They'll match. Okay, and on the right side, we now just have what, Carmi? Okay, on the left side, what are our factors going to be that multiply to 100 and add to negative 20? 10 and 10, but what kind of 10 and 10? Both negative, so that they'll add up to negative 20. Now, the reason it works out so well that they match is so in the next step, you can write it as a binomial squared. And you're only allowed to write something as a binomial squared if they match. But then after doing that, we're going to turn right around and do what? Square root it to cancel out that squared and square root this side. So now we have p minus 10 equals, is the square root of 136 a perfect square? No, so we'll just leave it inside, but plus or minus on the outside. Now the last step to get p by itself is to do what? Add this 10 over, and so that's where your two answers come from. The square root of 136 plus 10 and negative 130 square root of 136 plus 10. So go ahead and type those in to get your two answers. Bless you. Okay, when you type in the positive square root of 136 plus 10, what do you get? Well, let's not round all the way to a whole number, because if it were a whole number, it could have been factored, right? 21.66, so we'll round it 21.7. Okay, what about the second one? Negative square root of 136 plus 10. So 7, because it's 6, right? Okay, if you're going to stop at the 10th place, it's got to be a 7, because it rounds up. Now, that means if I plugged in 21.7 into both of these p places, it would equal very close to 0. Why do you not think it would be exactly 0? Because we've been rounding, okay? If you want it to be exactly 0, you can't ever round. But it'll be close enough for you to know you did it right, okay? Also, if you graphed it, you would see it cross the graph at between 21 and 22, but closer to 22, and then between negative 1 and negative 2, but closer to negative 2. Okay? All right, number 7. Number 7, can it be factored? 8 and 2. Okay, let's try with 8 and 2. Okay, what kind of 8, what kind of 2? Right. Okay, because they multiply to negative 16, they add to negative 6. And then at that point, I know a lot of you will start skipping this step that I'm writing right now because it's almost unnecessary. But I want everybody to understand why they're switching their sign and why this is becoming a positive 8 and why this is becoming a negative 2. Okay, what about number 8? Can it be factored? Okay, well, number 8 is one of those where even if it can, you might look at it and think, ooh, I don't know. Like, those are just bigger numbers. So if you're trying to figure out if it can, what can you do first? Graph it and see if it crosses through at whole numbers. Y equals x squared plus 16x minus 80. Doesn't it cross through exactly at 4? Isn't that a whole number? So we know one of our numbers is 4. And so 4 times what is 80? 20. Well, if it crossed through at positive 4 on the graph, how would you write it in here? Right, the opposite of what it is on the graph. So negative 4 and positive 20 multiplied to negative 80, do they add to 16? So see how handy these calculators can be for you? If you just know how to use them? Okay, so we would have to add the 4 over and end up with k equals 4, which we already saw on the graph. And then the reason we didn't see the other one is because it was way over at negative 20. That's why we didn't see it. If we changed our window and went left like negative 25 units, we would see it over there at negative 20. Okay, number 9. I'll give you just a second to catch up in case you're copying. Okay, number 9. Can it be factored? You sure about that? Okay, well, first, Maggie, think about it like this. You're multiplying to get what number? Yes, you do. No. What are you multiplying to get? 11. You do know. What are the only two numbers that multiply to get 11? Right, because it's prime. So you know your numbers are 1 and 11, but how can you make them add up to a negative 10? Which one? No. Right, if you want your number to stay in the negatives when you add them, the bigger of the numbers needs to have the negative. And then do those multiply to negative 11? So when you set each of those factors equal to 0 and solve, what are your final two answers? Which is where they would cross the x-axis if graphed, and the two numbers that make this trinomial equal 0. Okay, number 10. Can number 10 be factored? Okay, well, if you're not sure, what can you do? You graph it and see if it crosses through at whole numbers. X squared plus 20x minus 50. Okay, I only see it cross through once, and is that once at a whole number? No, so that means it can't be factored. We need to complete the square. So what's the first step? Add this 50 to the other side. And so we'll have r squared plus 20r equals positive 50. Then what's the next step? Right, you take your b value, which is 20, divide it by 2, and square it, and that becomes 10 squared, which is, right, you add 100 to both sides. Now on the right side, that just becomes 150. On the left side, you now have a perfect square trinomial. And what do I mean when I call it a perfect square trinomial? They're going to match. The binomials are going to match. Ignore that 8. Okay, so what numbers multiply to 100 and add to 20? 10 and 10. And they have to match so that in the next step you can write it once and square it. That's known as a binomial squared. And you're only allowed to do that if they match. Okay, now what do? Square root both sides to cancel out that 2. Square root this side. Is the square root of 150 a perfect square? No, so just leave it in there for now, but make sure you put a plus or minus because we took the square root. Now the last step to solve for r is what? Right? And so r equals the square root of 150 minus 10 and the negative square root of 150 minus 10. So go ahead and type both of those in. What do you get when you type in the positive square root of 150 minus 10? I got 2.2 for a square root of 150 minus 10. No, it goes on the outside. So 2.2, and then what did you get when you did the negative square root of 150 minus 10? Negative 22.2. So like if we were to graph this, which you could if you're trying to check to make sure you did everything right, you would just want to check to see if it crosses at 2.2, which doesn't that look about 2.2 to you? And then we can't see negative 22.2 because it's way over here, but if I went to my window and went further to the left to like negative 25, I would see the negative 22.2 over there. Okay, your classwork / homework is the next page. We have about 11 more minutes, so you need to be working in class to get as much done so that you don't have to do all of those for homework.